Hello everybody, this is Eccentric Stephanie here. I've been given a video camera for Christmas. Apart from the photos that I've done for the dolls' houses, I thought that you might possibly be interested in this. It is an LED small Edison screw bulb for 240 volts. I did in fact buy 56 of them for our own domestic lighting, and out of that many there was one that didn't work. Now I thought I will take it to pieces just to see what's inside, and this is where I thought that you might be interested. Well, this area about where the globe joins the base, I sawed through gently with a junior hacksaw, progressively sawing and twisting as I did so, until I could remove the globe off the top and reveal the inside. And the inside is like that. Now, to get this section out required the removal of some silicone rubber type material from around this area and the removal of that screw. Now, there is the screw there. Now, on the very base, that little nipple there, which is the input, one of the input poles, should be the live, is a little pop out nipple. There it is. I will see if you can see it just a little bit closer. If I bring it up, let it focus. It's just a tiny little thing. It just popped out from there to reveal the wire that was just trapped with it. There should be another wire attached to the metal screw housing. So then, if we now remove the actual element out, the lighting element, and we just have a brief look inside. Down there you can see the inside of the screw base, the two slots that the circuit boards slide in, and the screw hole which holds the assembly together. I did have to break off the wire that goes to the screw case from the inside, as there was no way of getting to it. So I did break that wire off and remove the unit. Now, as you can possibly see around this inside edge, it is aluminium coated with the plastic. Now, the aluminium touches the circuit board at the top, which is a method of dissipating the heat from the LED elements. So basically that is the base. So we'll put that to one side and pick up the actual circuit unit. This is the circuit unit. That is the small wire that goes to the nipple at the very bottom of the bulb, and that wire there joins onto the side of the Edison screw, making the two connections that are required for the bulb. We then have the circuit board here, which reduces the mains voltage down to something more reasonable and also converts it to DC. Now, if we turn the unit to face the camera, we can see that the two connections to the LED board, which is this top one, comes through this little plug. So we can now remove the actual lighting element from the circuit board. I'll put that to one side and come back to that later. Now then, the backing of this circuit board, again aluminium to dissipate the heat. That is the input terminals, which would be DC, possibly up to 17 volts, something like that. I can give you the calculations for that later if you wish. Now then, one of these is marked the positive. That's the positive input, and that goes to that LED. It comes out of that LED negative side and into the positive of the next one, and they are all wired in series round to number 7, which then connects to the negative. So as it's a series chain, that basically means one out, all out. So if one of these lighting LEDs fails, then all of them go out. That doesn't mean to say that each individual element has blown. It only requires one to blow, and the others then just fail to operate. Now, having studied this particular module, it can be seen that in the corner of each LED there is a chip under the orange surface. This is the controlling element for the LED. Now on these two it is virtually invisible unless one really zooms in on that corner. Now when we come round to number 3, one can see a black mark in the corner of the unit. Now experience would say that that one is the blown unit. We then go on to number 4, number 5, number 6 and number 7. Now number 7 looks a little bit suspect, as does number 6 actually. So we will get round to testing each individual one to find the fault. Now the reason I didn't take this back to the shop was, to be honest, it would have cost me more to get there and back and more stress than one particular bulb is worth. So that is basically it, and each one of these emits light, and it is a low heat device which increases the efficiency, which makes them that much more efficient than the incandescent filament lamps. So now we will pop that to one side and return to this. Now this is a very clever little circuit to reduce the voltage from the AC mains to the DC to power the LED units. Now this has a single-sided circuit board, which means that it has copper on one side and straightforward fiberglass on the other. Now if we look very carefully, we can see that there are components on both sides of the board. There is a bipolar or a FET device there. I'm not sure what that does. That is a bridge rectifier, so it takes the AC in on the one side and converts it to DC the other side, and that is a diode. Now there are small resistors and links on this side of the board. If we rotate the board over to look at the other component side, we can see that we have an inductor there and a capacitor there, another capacitor there, and that is another inductor. Also in there is a very fine inductor that for purposes here are a little noise suppression, but mainly as a fuse to protect from fire hazards or danger. This circuit here is what's termed a wattless dropper, which removes the dangerously high voltage and converts it to the DC, whereas these components here actually smooth that DC, make it a little less flickery on the LED units, and of course bring the RMS value of the DC closer to the peak, but that's a little academic. So what we have is the inductor or transformer. That depends on how many leads and windings it has. That is a small high voltage capacitor, and the inductor, the two capacitors, and the supply leads. So we'll put that down and return to this. So these are the LED elements. That's the connector, that's the screw. The aluminium connects to the aluminium on the inside to dissipate the heat, and the base, which is a small Edison screw, has the two connections, that one on the case and the small one that fits on the nipple on the end. So that goes in there like that, and that then goes on the top and is screwed into place, and then the actual cover, the globe, is welded or glued into place. So there we have it, a running quite cool LED fitting. We will just discuss the wattage and the equivalent wattage. Now this is a 5.5 watt device. Now over the years, wattage of light bulbs has been normalized as how bright they are, whereas wattage is actually a measurement of power rather than light. Light is measured in lumens. So as an incandescent bulb is over 90% inefficient, then the majority of that wattage is wasted on heat, very little light. So very small amount of bang for your buck. LEDs are very, very much more efficient than the incandescent bulbs. So if we look at the wattage, it is 5.5 watts. That is the power consumption, which is a lot less than, say, a 40 watt incandescent bulb. Now, as these are so much more efficient, then more of that energy is converted into light. Now this is where we get the equivalence table. So for a 5.5 watt LED lamp would be quite sufficient to replace in light value a 40 watt incandescent bulb. They would also last a tremendous amount longer and of course run cool. So actual light value is measured in lumens and power consumption in watts. So we must now learn to adjust in our minds how bright an old-fashioned 40 watt light bulb would be in lumens. Now I think this one, if I remember from the box, is about 470 lumens, which is the equivalent of a 40 watt bulb. So that's about it for this Right, I'm just about to solder a resistor onto the positive lead of this this wire that goes to my power supply, so we can hopefully test out each individual LED on that light bulb. Have I got my foot on the foot switch? Yes, there we go. This is my homemade soldering iron. Is a little bit Heath Robinson and a sort of project that isn't quite finished, but it's making it. Right, that's it, and I shall now solder that onto there. I have to be a little bit cautious with this, as the current that flows through this soldering iron, through this particular tip, to make this copper heated must be in excess of 100 amps. So as you can see here, that it's beginning to melt. So I shall put that to one side. It only works when I put my foot on the foot switch. So this might dazzle the camera just a little bit, but I have soldered on this 470 ohm resistor in the positive lead from my power unit, and that's the negative lead. I've got my power unit set to 9 volts, which should just start the LEDs working. However, it shouldn't make them too bright to be too much of a dazzle, and I'm going to try each one in turn. Now, that one is the one I suspect, as it's got the little black spot in the corner. Now, whether this is going to work to show you, I'm not sure. That's one, and the next one, and the next one, which is number 3, that's the dead one. Number 4, number 5, number 6, and number 7. So that means we have actually proved that as a series chain with the one out, all out philosophy, then that is the one there. So what I'm going to do now is to attempt to demonstrate where the chip lies in these other units. Now, I suspect that it is underneath the black spot, which is indicated by the faulty LED. Now, what I'm going to do is try and reduce the voltage to a working LED to such an extent that instead of being awfully bright, it shows the origin of the light within the orange square. I've reduced the voltage right down on my power supply, so hopefully the LED will just start to light, and it might be able to see exactly where the light comes from within the orange rectangle. There, can you see it? Yes, it's right down in that particular corner, which is the same corner as the one that's blown where the black spot is. So we have in fact identified that one as the blown LED, and as per the others, the actual circuit itself, or the LED element, is actually in that corner there. So that's it. We have in fact found the fault on this lamp. Now, if I had another one that was faulty, I could theoretically remove one of the elements from one and solder it into the other, but I don't think even my soldering iron is small enough to do that job. It's simply not worth it either, but it's always interesting to find out why something happens and what the problems might be. So I think we'll draw this particular video to a close now. I hope you enjoyed it. This is Eccentric Stephanie signing off just for the moment. Thank you. Goodbye.